This is a water bike that I bought off of Temu. I've already had my fun with it as is, and because this is an e-bike channel, I want to convert this thing to electric. Hey, what's going on? As I mentioned, I've already used this water bike as its intended purpose, but I want to convert it to electric. But before we do that, let me just show you briefly how it works. Now, I have a whole other video on my other channel on how this works and functions as intended. So I'll link that at the end of this one. This video is going to be quite the experiment that I'm really excited for. Hopefully it works. But first, let's just kind of talk through how this works. Now, you have two pontoons that are essentially like two small paddle boards. And then up here, you have your steering, which hooks to these two wires that run through the frame, out the back, and then this connects in through here, so through this gearbox, and then as you pedal, it spins this propeller here. Now, the drive is a belt drive. It's not a chain drive because you're out on water and chains can rust, so that's pretty clever there. This is where I'm going to run into my challenge of converting this to electric, because I've actually bought a mid-drive motor that I want to use to do this. So let's unbox that first and then we'll tear into the bike. All right, so let's dig into the electric motor and see what's in the box here. I actually ordered this off of Temu as well, but it's a Bafang motor and it's a mid-drive, meaning that it hooks right into where your pedals go and the bottom bracket there. So hopefully there's enough clearance for that. Also in here are a couple of sensors. This one is for your speedometer, which hooks to a tire. We don't have a tire, so I don't think we're gonna use that. Here is, I think this is the thumb throttle. Yep, so that's what's gonna make it go, is this nice thumb throttle here. These parts are for your bottom bracket and it will hold the motor in place. Don't want to lose those, so we'll keep those separate. This is kind of funny, debating on whether or not I should use this or not, but comes with a little headlight. So if I can figure out a way to attach that, maybe we will, just for fun. These are a couple of the tools you need to remove the bottom bracket. We'll get into that in just a second. Now this is a 750 watt motor. That should be plenty of power. In fact, I'm kind of nervous that it might be too much power. All right, let's check out the battery. So this battery is by Varstrom. Here is the battery. We might have to get creative with this. Let me just show you why. I was hoping that it would connect into there, but there's just, it doesn't sit, well, does it sit flat? It doesn't quite sit flat. We could get clever, and because this is like a floating craft, maybe I don't even have to attach the battery. I can just like put it in some waterproof bag off of the bike somewhere. We'll see. We might have to get creative there. That's the battery, and just looks like it comes with a couple of attachments, and then of course we have our charger. A couple of other things in the box. Now this is meant for an e-bike, so here's the chain ring there. Obviously we're not going to use this. That is a pretty nice filling chain ring. It also came with some brake sensors. There are no brakes on this, so we won't be using that. That will go in the unnecessary pile. Oh, this is your display. I guess since I bought this off of Temu, I should probably make sure that it works before tearing apart the bike and installing it. So we're just gonna do a little dry run here, total pun intended. But let's hook up this wiring. I'm gonna call it a wiring harness. I don't know if that's what you would call it, but that just plugs in there. Careful not to bend any wires. And then we have our display. I don't see where that would go. That's not good, because I'm thinking that would power our display, but it's the wrong size. All right, first obstacle. Figure that out later. And then this, I would think, should just go to the throttle. That just snaps right in there. And the battery plugs in right here. But because that display doesn't plug in, that's not good. That's why you always check before you tear things apart. Might have to reach out to the manufacturer. Let's see if this even does anything with the thumb throttle. Nope. Probably have to turn it on. First problem. Alright, so while we troubleshoot that connection problem, let's take a look at what it's actually going to take to mount this mid-drive motor to the bike here. So I got to remove this sprocket here with the belt drive. Got to remove these cranks and pedals, and then this will fit right in here to the bottom bracket, hopefully, if all goes well. And we should have plenty of clearance with the motor. I was concerned because of this bottom piece that you don't find on normal bikes. I didn't know if there's going to be enough space in there, but it looks like there's plenty. So now we just need to remove the sprocket, the cranks, and the bottom bracket and fit this in. I'm going against what I just said of making sure everything works before you install it, but I just cannot wait to get this done, and we might as well get some headway while we troubleshoot other issues. So we'll use this tool that comes with it. You just screw that in, and then you screw that in, and the idea is to pull out the bottom brackets. Alright, so I ran into another snag. This bottom bracket seems to be a sealed bracket, and the bottom bracket tool just does not hook in anywhere. There's no teeth to grab anything, and so somehow we got to pop out this black ring here and remove the whole thing out of there. That part, I'm not sure how we're going to do, but we'll figure it out. Alright, so just before we give up for the night, we're going to give it one last hit. We've definitely damaged this thing, so here goes nothing. Oh! So we trashed this thing. But now, this is what I fear. This might be what we have to come back to. But these circumferences do not match. But at least it fits in there. I'm going to do some research and hit this again tomorrow. What have I done, Tyler? It's the next day and I'm back working on the electric water bike. I know electric and water don't mix, but we'll cross that bridge when we get there. Anyway, the bike looks like it's in shambles, and make no mistake, it is. One of the problems that we face with the motor is that the casing for the mid-drive mount is too big and the spindle here is too small. And because it's 2025 and technology is at its all-time greatest, I jumped on ChatGPT, and I kid you not, after several prompts, I was able to have it design an adapter that reduces the bottom bracket shell so that my mid-drive motor spindle mounts in here. Now, there is some play in there. This is just a prototype, so I might need to redesign that to make it fit a little bit better. But for now, this will at least work to get it mounted. But I can't believe that in less than 24 hours, we were able to solve a pretty serious problem and come up with something that might not exist out there in the world. Maybe it does, I don't know, but it's gonna work for now. Also, within 24 hours, I was able to identify the plug to the display, because as you remember, my display did not fit the right connector. So let's see if this one will work. So the connector that I needed is this one. It's a C8N protocol. Don't know exactly what that means. And the one that I was sent is a UART, and that's a female. I needed a male version as well. And so now that should connect just fine into my wiring harness here. So again, before I get too far into this project, let's see if I can now power up the motor. So the motor is working. Nice. So as I'm looking at this, we might have another issue that we need to overcome. I'm not going to use this chain ring, but this will help set the example. Because we have this extra piece right here from the hub motor, then looking down, this is the rear sprocket and it's offset. Once I get this mounted, maybe that'll illustrate it a little bit better. I mean, we are way off at this point. You can see just how off we are with the belt. I'll get it as close as I can eventually, but I might need to create some sort of extender to line up the belt sprocket and the rear sprocket so that it works. But again, we'll cross that when we get there. I kind of want to get the handlebars all set up and mounted just to get some stuff out of the way. So let's do that right now. So what I have is the tube that comes down with the propeller and the rudder, and I want to make sure that that's nice and straight, and I'll lock that in, and then I'll adjust the handlebars so that we are nice and aligned there. Got the display and the control all mounted on the handlebars there. All right, so let's talk about mounting the motor right now. So there is some play in here, and this piece that I designed, or that ChatGPT designed, is a prototype. And so I actually ended up buying some calipers so that I can get some exact measurements, and I think that that will help me quite a bit on getting what I need. The other thing too is I thought I should extend out the casing, so I added this little lip right here, and that's fine, but when I add this motor mount, so put that on there, there is now a gap, so it's not quite flush. I'm gonna roll with it just because I want everything to kind of like clamp together, and we'll just see how that goes for now. Let's get this thing mounted up. Also, because this is a prototype, I used PLA. It's kind of the cheapest filament. Didn't want to get too crazy on it being expensive. I mean, I can really crank this down, but then the PLA will probably start to crack, but it's already feeling pretty secure. I don't want to go too crazy on that, but that's feeling pretty good. Maybe I'll just give it one more rotate here. Okay, feeling pretty good about that. Now let's see if I can screw these in. You know, another thing I could do there, probably want to do is put some washers in that. Wouldn't be a bad idea. But then this goes on and covers the inner ring. Then you just tighten it with this tool. Kind of clamps everything down. That feels pretty dang secure, if I do say so myself. Got the mid-drive motor all mounted up, and I might keep that prototype in there for as long as I can. I'm not too worried about it, mainly because this is going on water, so it's essentially a smooth surface. Now, I could worry about torque of the motor and stuff like that really causing some havoc on it, but we'll just see how it goes on my initial test run. If not, we can go back to the drawing board. It'll be easy to remove, and we can make something a little bit more stronger, but I'm gonna keep that in there. I'm pretty happy with this. I have some washers in here stacked, so that kind of creates a spacer to compensate for that space, and everything is pretty clamped down and tight here. We're getting closer, but we still have a few problems to solve. The biggest one is where to mount the battery. I was really hoping I could mount it right here, as I pointed out, but this base is just a little bit too long, so we'll figure that out. The other is, this is a 4-bolt pattern, and the mid-drive motor is set up for a 5-bolt pattern. Now, I do have an adapter coming tomorrow, but I'm still worried about the offset that we're facing with the belt drive. So it's just not going to be lined up there. So we got to figure out a way to compensate for that. And the other issue that I'm not super concerned about is what to do with all these extra cables and how to store them for some cable management here. But let's just get everything kind of hooked up as is, run the motor real quick, and we'll go to our next steps when my parts come. All right, it's on. It's kind of hard to see the display. Okay, it's on Eco, and let's run it. There we go. Power's up. So we're getting somewhere. Oh, what's the error? Why did I get an error? E21. That's not good. No error that time. I'll have to research that. But I do like this setup. I like how it looks, and I cannot wait for this to just pedal me through the water. Back at it with the water e-bike, and the part that I needed to attach the belt sprocket to the mid-drive motor is here, but it presents a couple of problems, but I think I have a solution. So the way that it works is it just goes right over that, and then you screw this in, and then you put this over the top of it. But as you can see, that center hole is too small. So even if I wanted to screw it in, I couldn't, but also it's blocking me from being able to bolt this thing to it. So there's no room for screws. So what I'm thinking is taking this whole drill, and this is a 2.5 inch circumference. This is a 3.5 inch circumference. So I measure a 1/2 inch out all around, and then that should get me centered. If I don't get it exactly centered, it's not the end of the world, because I'm not screwing anything into this that would attach to the hub motor. This is what would keep everything centered there, but I'll get it as close as I can. It just doesn't need to be an exact science. So let's get this attached. I think that works pretty well. It might need a little bit more clearance. I think it's going to do. I think I'll be able to get in there and tighten things down. So what I'll do is I'll mount this plate to my belt sprocket and then get them lined up and see if I can't tighten the screws in there. And we'll see how the belt lines up. So I think I actually need a little bit more clearance right here, because putting this on, then there's just like a couple millimeters of overhang here that makes it impossible to screw in these bolts. But I think I'll just kind of chip away at this. I don't want to get too crazy because I don't want to ruin this thing, but we'll get some more clearance, and then that will make mounting this a lot easier. Well, from far away it doesn't look too bad, but up close, that's a certified hack job. but I think it's gonna meet our needs now. So let's put this thing together. So it just dawned on me that I have to get the crank on here too. So I still am gonna have to work around some weird clearance stuff to get these tight. So, okay, let's start with one here and just see where it gets us. And we have ourselves a belt sprocket. All right, let's see how this belt is gonna work. It sits up over that. Pull this tight. Come on. I know it's offset, but we might be okay. And I can adjust this tensioner right here. I think I can loosen this up and pull it out a little bit so that belt is staying tight on the sprockets. So I'm just gonna loosen this bolt a little bit, give it some wiggle room, and that can kind of play a little bit more. I don't want to go too loose here. See how this behaves without anything, because worst case scenario, I just buy a longer bolt. I don't think I have one here, but I just go get a longer one and adjust it out to about there with some washers and stuff, and I think that would work. But this is pretty tight without it, but I still think I'm gonna need to space this out a little bit, because when I'm pedaling you can hear it catch on these guards here, and that could cause some issue. But also, let's get this belt sprocket tightened on here so we can get a clear picture of what we need. And you'll want to tighten these in a star pattern so you make sure it's nice and even. Here's a better angle of the issue that we're facing. So I need to figure out a way to bump this sprocket out, because if I don't, I mean, you can see it's twisted. The belt is twisted, so we got to get it lined up there. And then if I were to just leave it like this, it would just wreak havoc on the belt and probably the sprocket and just not be good. So that's something that I've bumped into. However, I think I have a temporary solution to get the battery mounted right here. Eventually I do want to 3D print kind of a plate that's a riser that will put the battery up, and then I can fasten the battery somehow through here. That'll be a project for another day, but I'll actually see what it'll be like to use this styrofoam. So we'll ratchet down the battery and the plate on there and just see if that works for now. We are getting so close. I really want to take this out tomorrow. Okay, I know this isn't ideal, but it feels like it's gonna work for now, and I don't think I could have found more perfect ratchet straps. What's crazy is they actually came with this cart that I bought that'll help me move my mini boat around, and that just showed up today. And the fact that these ratchet straps are short, they have like this protective flap here, that couldn't be more perfect. It's starting to look like an e-bike. Let's hook up the battery, and then we can think about cable management. So against my better judgment, and with the belt the way it is, I know I probably shouldn't do this, but I really want to see this thing work under its own electric power. Oh my gosh! It's alive! So cliche. So as you saw, it's working. I'm just turning it on again here. But something weird happens. So it goes. I let off. Oh, let's see if I can get it to throw the air. And of course, now it's not throwing the air. I don't want to trash anything, but essentially what was happening, it's showing like an E21, and I looked it up, and what that means is a speed sensor error. So This is meant to attach to your back wheel. This goes on your spokes, and every time it passes by this sensor, then it tells you how fast you're going. Well, I don't have any wheels on this thing, as you can see. So my hope is to just trick it by always having the magnet near the sensor, and it'll always just show 0 miles per hour up here, but that's not a big deal to me. I'm not too worried about how fast I'm actually going. It would be kind of fun to know, but there's phone speedometers for that. So I gotta hook this up somehow and trick the sensor and just have it always showing 0 so I don't get that error anymore. Okay, so I think I have my solution, and I'm actually gonna make the speed sensor somewhat functional. I'm going to attach the magnet to the actual belt sprocket, and then here's my speed sensor here, so that now when I throttle, it should actually give me a reading. I mean, that's not going to be my actual speed, but hey, we'll pretend like it's the motor speed or something. You know, like well, I guess it would be the RPMs, right? But it wouldn't be RPMs. Would it? No. Anyway, I'm going to figure out how to secure that magnet so it doesn't come off. Because if I lost that, then I'd really be in trouble. But this is really coming together. Speed sensor. Need to get that fixed. Need to get a longer bolt for this tensioner here that goes in right there. And then I need to figure out how to space this out just a little bit more so my belt is lined up. I've taken this bolt off here, and this feels super secure, so I don't know how to get this rear sprocket off, but I'm gonna give it a try. So I just took the existing notch in this magnet setup and clamped it in with my channel locks here, and then I'm just gonna glue stick it in. It feels pretty secure, but I'm just gonna glue it in a little bit more. Just put some gobs of glue. Hopefully that will secure that. So I'm just about at a stopping point tonight, but I did figure out that I could use my tire iron here to gently pry this sprocket off. Probably not the best idea to do under tension with the belt, but I just want to see what we got going on here. I mean, that's lined up better. I'm wondering if I could get some washers in there, and might take a longer bolt right here. And then once my tensioner is sorted out, we might be in business. All right, it's time to finish this thing. It's one of the last nice days of the year. I want to get this thing up onto the lake. So I ran to Home Depot this morning and I got what I think I need. So got a big old long bolt to stick through there for this belt tensioner. Got a couple of cap screws so that it's a little bit longer into this spindle here. I also got a spacer. It's slightly smaller, so I'm gonna have to hammer it on. Hopefully the nylon doesn't break. And then a few rubber washers to help space it, as well as a few other nylon washers just to get the lineup right. Really, the solve here would to have a longer spindle, but I just don't have time or the skill to make that happen. And then a few other things that I need here. So let's try to get this thing put together. I think I'm gonna put the rear sprocket on first and get that squared away. Maybe I'll try dremeling it out a little bit, give me some more space there. I think we'll go that route. Now it should fit on, and it's pretty snug. That's looking pretty good. My concern is now I don't have a lot of spindle left to work with, and with this kind of hanging out on the edge there, you know, some amount of torque could kind of pull it. So again, I wish I could make this a little bit longer. However, I do have these longer cap bolts here that should help. I am still going to put on a neoprene washer here. That way it gives a little bit more friction against this nylon spacer. And I'll just crank that down super tight. And that should be pretty good. Now I got to get this on under tension from the belt, unless I want to undo that whole thing, which probably be the better option. But we'll try this option first, just getting the belt on and tightening it down. I think we're pretty lined up. A little grab there, but maybe putting the tensioner on will help. All right, now it's time for the tensioner. Let's see how this is gonna go. Just wanna get all my adjustments right here. Let's try this. Oh, now that doesn't even spin. Okay. Don't want that. Need that to spin. I am thinking that I should add one more washer. We're just slightly off right here. My biggest concern is just torquing too much on this thing, but might as well try it. So what's happening with the angle, if you look right here, these notches or these ledges will catch the belt. See that? And kind of push it. And over time, that would just eat into the belt. Now, I don't know if that would be something that would self-correct and just kind of like wear these edges off for me. But then that might ruin the integrity of the belt. I don't know. Well, I've been doing a lot of things on this project against my better judgment, so might as well roll with this one. I actually put one more nylon washer on, and sounds better than it did. I really think it'll eventually just kind of wear down that side and be a little bit more smooth. So we'll see, but it's almost there. I just have to put on the cranks now. I think that's it. Then we're ready to take it to the lake. And there it is, after 3 full evenings and 1 Saturday morning, the electric water bike is ready to go. I hope. Time to get this thing loaded up and head to the lake. I cannot wait to see how it works. So I got it all down to the lake. Just me. I guess you can do this as a one-man show. Anyway, it's kind of windy. There's a lot of people around, so that's kind of fun. But anyway, we're gonna get this all set up. I gotta inflate the pontoons, hook them up to the bike, and then we're ready to test this thing out. And here it is, all set up, ready for its maiden voyage. All right, initial ride of the electric water bike. The time has finally come. Oh, why am I nervous? Here we go. Ooh. Doesn't help that it's windy. Let's see if I can reverse it out of here. Oh, I don't got reverse on this. I forgot, because now it's a freewheel. So now it's not gonna work with reverse. So I just gotta try to go for it without tipping the whole thing over. There we go. Oh my gosh, it's going. It's not going very fast though. I'll tell you what, with the pedal assist, it's nice. Let's crank this up. Oh, that's on boost. I mean, it goes, but oh, it's not going very fast. Oh man. Let's try pedaling. It's just not going like it should. I'm just stuck. It's not spinning the motor very fast. Oh man. This is not doing what I'd hoped. Oh man. I'm like stuck out here with the wind. Oh, it worked better fixed. I just don't think the motor pushes enough power. Fixed, it went great, but it's not doing what I'd hoped. It doesn't go anywhere. It just doesn't have the power. Oh, the screw fell out? Oh, it's slipping on the spindle. It's doing exactly what I worried about. And I might have ruined the gear, or the sprocket. Like tighten the screw all the way in. This is me looking in defeat. It's not about the destination, it's about the journey, right? Right now, I have a $1,500 useless water bike. Plus side is I could use the motor for something else, but I want to figure this out. We're not done with this yet. So what happened was this rear sprocket, because it's not grasping the full spline, it's just not doing what it's supposed to, and the screw in here is like melted in, and it's just not good. So back to the drawing board. Well, at least the propeller on that thing worked. I am back with the bike and just trying to figure out what went wrong. I watched the video and the prop was turning, but it wasn't turning as fast as it should have. But now, when I get it home and test it out, it turns plenty fast. So I don't know what's going on, but let me show you everything. So I have the battery hooked up, and as you can see, it's spinning pretty fast, but look right here, that is definitely wobbly, and it's causing some wear on the belt. So I've damaged this rear sprocket here, and so let's take this off and see what we can see. And the belt is starting to wear too, so I don't know if it's starting to show wires or what that is, but I don't want it to get any worse than it is. I'm sure it wouldn't be too hard to find a new belt. It's this piece that I'm worried about. So this bolt just kind of like melted through the sprocket here. This side still looks fine, but you can see I just don't have much to work with. And I knew that that was going to be a failure point, so I'm kind of kicking myself that I didn't take some measures. But I was just excited to get this thing on the water. I think the only solution for this to correct it is, one, to find a replacement, which I don't know how I'm going to do that, and two is to somehow extend out this spindle here. It's going to be tricky. In other news, my ratchet straps and styrofoam held together quite nicely, but I am working with another friend to get something 3D printed here, so hopefully I'll have that as a more permanent solution. But I really got to get this thing riding because it is October and it is getting cold. Look at that, the leaves are already starting to change. But that hasn't stopped me from testing crazy boats before. We're gonna get this thing going before the lake freezes over. Mark my words. So I've been working on this water bike for just over a month now, and I think I finally have all the different components that I need to get this thing running. Currently, it's in disarray. We have the belt hanging off of the seat. I need to get the battery remounted and also this rear pulley so that my propeller will turn, because I've trashed the original pulley here. So with a bunch of prompts, I actually got ChatGPT to spit out this design for me, and I had a friend of mine print it, and it was fine. It slides on there, but the offset sticks out too far. And also the pattern on the pulley doesn't quite match the belt profile. So I kid you not, I probably spent another 3 hours on prompts, and I finally got to this. And now I have a pulley that I think is going to work. I think my offset is on a little bit more, so I want to get that installed. But I also have another 3D printed piece that I want to install. So on my first test, I used this piece of foam and ratchet strapped the battery. And the reason why I had to do that is because the mounting plate is too long for this diagonal piece of the frame and the vertical seat post to come in, and it would make it so this would be bent if I tried to secure this down to the battery. And then I also wouldn't be able to slide the battery on and off. I probably already explained that. Well, I reached out to my friend over in Turkey. Yes, I do have a friend in Turkey. We've actually met in person, and he helped me design this piece that is a riser. So now I can fasten the battery mount to that, and then I'm gonna actually glue this down and use some zip ties to secure it. And now the battery sits in a nice spot there. I mean, I've been obsessed with 3D printing ever since, but the fact that I was able to think of something, talk to a friend who knew how to do it, and he helped me design this. And then through the power of AI, I was able to design this complex piece with no CAD skill. That's probably the most exciting thing about this right now, other than if I can actually get it to run better than I did in my first test. So let's get the belt put back on, see if we can get that lined up, and then we'll mount the battery. Looks like I will need a longer M6 bolt here, but that'll just help secure everything. I'm so happy with how that turned out. So the way that this is going to mount is we have our screw holes here, and the plate just sits right on top of that. So we're actually going to screw the plate into the riser. Then my goal there is to glue it down, of course, but then also we have some holes to tie some pretty thick ratchet straps through. So I know that's not the most secure. The best thing to do would be to drill into the frame and do some riv nuts there, something along those lines, but we'll see how this goes. I can always get this redesigned if I need to, but I really think that this should suffice for what I'm doing, because it's not like we're taking it on bumpy roads where it'll rattle off. It's going to be on smooth, even flowing water. So I don't need it to be super rigid. So we're going with epoxy super weld. So this takes about 90 minutes to set up. So we'll let that set up, and then we'll throw the zip ties on and plug this thing in and see how it works. So the epoxy is set up enough that I feel like I can put the battery on here. I also got my zip ties to hold it in place. And so we're just gonna mount the battery here. So now you can see that I got the clearance that I need. It looks complete. Let's plug it in and give it a test. Okay, it's all hooked up, ready to go. Let's test it again. Nice and smooth. Just to recap, we got our power settings there, our display, the thumb throttle, all the wiring runs down. Got our battery, our mid-drive motor, our modified sprocket, and a belt pulley system that's been 3D printed, and also a 3D printed riser and a 3D printed adapter here so that the bottom bracket all fits. One thing I am concerned about, and maybe this has been the problem all along, is the propeller. Maybe it just doesn't have enough pitch to propel through the water at that speed, and it just churns it. And maybe that's what the problem was all along. There was just kind of too much going on as I was testing it. But we're gonna find out tomorrow. Tomorrow is November 1st, so that water is going to be freezing. But hey, I gotta make sure this thing works. And then of course, if it does, if there's some adjustments I need to make, it's gonna be a fun summer next summer. But I just gotta get this thing working. Oh, and I gotta shout out my friends Austin and Nacho for helping me with the 3D printing stuff. Couldn't have done it without you. Here I am up at the lake, November 1st. Hey, there's no wind and the water's smooth, so at least I have that going for me. Let's see if this thing will finally work as an electric motorized water bike. Okay, here we go for round 2. Hopefully all this waiting and all of this configuration was worth it. It's on. Let's launch her. Ooh, that's cold water. So one thing I was curious about was if I didn't have my prop all the way extended down. So I want to double check that. So I think I'm good there. Whew, this is cold water. I do not want to fall in. Oh man. Okay. So I'm just going to start out slow. Here we go. Oh yeah. It's going. Yeah. Woohoo. Heck yeah! That is not super fast. That is sweet. Here we go. It's actually working. The electric water bike. Oh yeah. Steer's fine. Oh, this is awesome. It's actually working. Yeah! Yes! We did it! Oh, no! What happened? Uh-oh. What was that noise? Oh no. I don't know what's going on. I gotta limp it back. Maybe the belt got wet, so it's slipping. Oh, I gotta limp this back. I don't like that sound. I don't know why the belt would get wet. Something's slipping. It might be my sprocket. Looks like I might have to reinvent the sprocket. I don't know. We'll just get it back to shore and see what we can find out. I don't know if you can hear that noise, but okay, so now that I got it back on shore, I can show you a little bit closer what's going on. Maybe you can see it in there, but the plastic, I used ASA, and I thought it would be strong enough, but it looks like it's just wearing down those teeth there. And so that popping noise, if you could hear it, was the belt slipping. I just need to print higher peaks and lower valleys, possibly on a stronger material there. But yeah, it looks like it's pretty much melted. But other than that, it was working as it should. Definitely a lot better than it was last time I had it up here. Even though this didn't go exactly how I wanted it to, I was still able to prove the concept that I could make an electric water bike. Going into this round, I was worried that it was actually the propeller that was going to cause the problems. Maybe it wasn't built to propel me, but it did just fine, as you saw. So it's actually the rear pulley that continues to be the weak point. So that's why we do these things. We build them, we break them, and we build them stronger. So I'm gonna spend some time on that rear pulley, make sure that I can get one that actually works. And of course, if you have any ideas of what I could do on that pulley, I'm not an engineer, maybe one of you are, let me know in the comments down below. Anyway, that's gonna do it for this video. If you like it, go ahead and hit that thumbs up button. And again, comment down below, let me know what you think about this project. I'm eager to hear your thoughts. And of course, while you're down there, hit that subscribe button. Have a great rest of your day.